Satyabama Institute of Science and Technology.
Good morning. I am Anbu, Assistant Professor in Satyabama Institute of Science and Technology. We have a short video on decision tree. So first going to decision tree. So what's machine learning and what is supervised learning and unsupervised learning? So supervised learning is nothing but, so first the model is trained with the training data set. Okay, so here we have one example. So the training data set consists of both input data as well as output data. So that input data x is mapped to the output function y. So here we have some labeled data, and here the labels are hexagon, square and triangle. So if the square means we have 4 sides are there, it is a square. If it is 6 sides, then the label is a hexagon. If it is a 3 sides, it's a triangle. So it is already the labels are given, then it is trained with the model, and the output is given as whether the shape is a square, triangle or hexagon. This is a supervised learning. If it is a unsupervised learning, the input data set or the data set does not contains the output. Only the raw data is contains. Okay. So why we go for unsupervised machine learning? It helpful for finding the useful insights from the data set, and it is similar to human being. That is how we have to think. Just like that, it will train the data from data itself. So it works on unlabeled and uncategorized data, that is unsupervised learning. So it is in real world, all the data does not contain the input as well as the output. So we go for unsupervised learning. So here we have one example, that is here we have a raw input data. It contains some images. So the images are some dogs and cats. It is first it should be interpreted with some features. So whether all the images are having same type of legs or some types of hands, and with the help of suitable algorithms, it is classified into some groups of clusters. Okay, whether it may be a cat or it may be a dog. So next we go into a decision tree. So decision tree comes under the supervised learning. Okay, so it is a tree structured classifier. So tree structure means here we have some of the nodes. So starting from the root node, and we have a sub nodes also there. So here we have 3 types of nodes. First one is internal nodes. The internal node represents the features of the data set, and the branches represents the decision rules, and the each leaf node represents the outcome based on the decisions. So here mainly we have there are 2 nodes are there, decision node and leaf node. So the decision nodes are used to make any decisions and have multiple branches also there. So here the leaf nodes are the output of those the decisions and do not contain any further branches. So the decisions are performed on the basis of the features of the given data set. So if it is a graphical representation of getting all the possible solutions to a problem or decision based on the given conditions. Okay. So here we have a COT algorithm is there. So the COT is nothing but classification and regression tree algorithm. So COT is for regression problem, and for ID3 algorithm for classification problem. Okay. So here the decision tree simply asks the question. So you have to ask a question, based on the answer. Further, it can be divided into a sub nodes. Okay, and the below diagram explains the general structure of the decision tree. So here we have a decision node. This is called a root node. Again, we have the decision node is divided into a again decision nodes. So based on the questions and answers. Here also we have decision node and another one decision node based on the answers, that is yes or no. So for any one question we have answer is yes or no. For yes, we have one decision node, and another one is no for another one decision node. Again, it is further divided into a sub nodes. If it is not not divided, means we have a leaf node. So it cannot be further divided. So here we have one decision node. Again, you will have one conditions. Based on the conditions and the output of the questions, we have again further divided into a leaf node or decision node. So some of the terms we have in decision tree algorithms. So first one is a root node. So this is a starting node. So starting from this node only, we have the decision tree is started. Again, this is divided into 2 or more subtrees. And leaf node, this is a final, that is last node or final node. And splitting. So splitting is nothing but the process of dividing this decision node or root node based on the conditions. Branch or subtree, a tree formed by the splitting the tree. pruning. So pruning is to delete the unwanted nodes and parent or child node. So the root node is always called the parent node. The remaining nodes are called the child node. So how does the decision tree algorithms works? So for this is based on the question and answer only. So the root node is selection by the ASM method, that is attribute selection measure. Which one attribute is having more information, that node is called as a root node. From the root node, further it is classified into some further nodes. So for step 1, so begin the tree with the root node, say yes. So this contains all the attributes. And step 2, find the best attribute the dataset using attribute, that is ASM, attribute selection measure, and divide the S into subsets, contain possible values for the best attributes. The next step is to generate the decision tree node which contains the best attribute, and recursively make a new decisions based on the conditions. It will be further divided into nodes. So we have one example here. So if suppose a person is attending an interview and got some offers, means first of all the first question is how much the salary. So if this based on the salary only, he will choose the job or not. So based on the salary, so if the salary is between 5 lakh to 8 lakhs, he is going to grab the job or not. So if it is going to get the job, means then the next question is the office is nearby his home or not. Based on this, if it is okay, means then he will choose. The next question is they will provide a cab facility or not. So based on these conditions, we have to split the nodes. So if it is not further, if he is declined the offer, means this is a last node, that is leaf node. So this is the example for a decision tree. So here we are having information gain and Gini index. So with the help of the information gain only, we have to select the root node. So which attribute having more information, that is acts as a root node with the help of the information gain. So the information gain is given with the help of this formula, entropy of S minus weighted average into entropy of each feature. We are going to find out each and every attribute for the entropy. And entropy is a metric to measure the impurity in a given attribute, because each and every attribute can have some informations. So whether which one is having the more informations, we have to choose that attribute, and remaining attributes are rejected. Okay. So the entropy is given by probability of yes log to probability of yes minus probability of no log to probability of no. So here yes and no is nothing but we have a positive answers and negative answers also. Okay. So this P of S is probability of yes and probability of no. So next one is Gini index. So Gini index is nothing but we have to find out the purity or impurity of each and every attribute with the help of the CART algorithm. So if it is a low Gini index, means we have to reject the attribute. If it having any attribute having more Gini index, then you have to select that attribute for a decision tree. So this is given by the equation 1 minus sigma j pj 2. Next one is pruning. So pruning is it is a process of removing the unwanted nodes in the decision tree. Why we are going to remove the unwanted nodes, means if a tree is too large, means we have a overfitting problem. If a tree is very small, means it cannot have all the informations in that particular tree. So that's why we have a pruning process. So for we have two types of pruning technologies. First one is cost complexity pruning, and next one is reduced error pruning. So next one is what is the advantages and disadvantages of decision tree. So advantages of decision tree is it is very simple, because like a human being we are having more questions and answers. So like that this algorithm also find the possible how much of solutions are there for a particular problem, and also think about all the possible outcomes of a problem, and there is a less requirement of data cleaning compared to other algorithms, because the data set contains both inputs as well as output. And what is the disadvantages of decision trees? It contains lots of layers which makes it complex, because we have to compute for each and every attribute for the information gain and Gini index. So further we have more computations also there. That's why we have it's more complex, and if it is an overfitting issue, it can be resolved by using the random forest algorithm for more class labels, because we are having it's a supervised learning. We have suppose having more number of labels, means we have to more complexity for performing this decision tree algorithm. Thank you.